Okay, so worksheet 3, here's number 1. Okay, so I'm looking at the problem saying, well, do I see any identities here? I see a bunch of squared, so I'm always going to be targeting the possibility of applying a trig identity, Pythagorean identity. I see 1 minus cosine squared. That's an easy spot for me to make a substitution. Replace cosine, replace 1 minus cosine squared with sine squared. Okay, so we know we're having an easier time here because there's no more subtraction going on. We like everything being multiplication. We know that things will be easier to cancel out when that's the case. And now I'm just thinking, well, I can have an easier time matching these parts if I can have everything showing to be the same functions. So let's go ahead and convert that secant squared to be in terms of sine or cosine. We know secant is the reciprocal of cosine. And then conveniently, sine squared over cosine squared will turn itself into tangent. And we're at the end. Okay, questions with 1. Okay, number 2. Cotangent squared, cosecant squared minus cotangent squared equals cotangent to the 4th. We're looking at this side. Maybe you're thinking, oh, maybe I convert everything in terms of sine and cosine. Now, I'm always looking at the right side to kind of give me a hint as to how I should start my problem. I'm thinking maybe I just leave it in terms of cotangent because I already have cotangent. So looks like I don't really have to convert everything to be in terms of sine and cosine. Now I'm looking at this a little closer and I'm thinking, okay, these are 2 separate terms, but both terms share a common factor. What if I take those factors out? Maybe something will reveal itself after I take that common factor out. So my common factor is cotangent squared. When you take a common factor out, what that means is that you're dividing all your terms with that common factor. So I want to remove cotangent squared from both terms. What that means is I want to divide both terms out. First term, I'm left with cosecant squared. Second term, I'm left with what? What does this become? Just 1, right? Not a 0, right? It's a 1, right? Negative 1. So now this feels more familiar, right? We have something available to us that was not there before, and that is the trig identity of cosecant squared minus 1. We know cosecant squared minus 1 is just cotangent squared. And now we have everything in terms of cotangent squared, which is perfect. Cotangent squared times cotangent squared. We add the exponents. 2 plus 2 is 4. Questions with 2. Okay. Number 3. So number 3, I see 2 terms on the left, but I see 1 term on the right. That's a big hint that we probably want to do common denominators, right? We have an easier time putting things together if I can have everything under 1 fraction. So some of you jump into finding common denominators, which is fine. For me, I was a little worried about that secant. I want everything in terms of sine and cosine, so I can just have a better view. I didn't want that secant to kind of come back and haunt me if it ends up being a different denominator. So I'm going to convert this secant to be in terms of sine and cosine first. I want to do a little bit of cleanup with this fraction, get a better idea before I jump into common denominators, just because I was a little worried about that secant. Secant is 1 over cosine. 1 over cosine divided by sine is same thing as multiplied by the reciprocal. So 1 over cosine times 1 over sine is 1 over sine cosine. Now I'm back to my original problem here. But this feels a little better for me because at least everything I see in front of me is in terms of sine and cosine. So now I'm going to move towards my common denominator work. Oh, yep, the worksheet there. So what's our common denominator between these two fractions? Cosine and sine, yep. Oh, shoot. Yeah, let me print it somewhere else. All right, see you.
I guarantee you, common denominator. I guarantee you on being 210 or 261. One minus. Oh, 181. So 181. Actually, it's not. No, it's not right. You're right about that. Future. This is one. Looking at it. You said, yeah, you did have that. No, because then it said John might have 14. Oh, because he was probably. Oh, did he count points standing in? Okay, dollars. Last night I was like going to review and I got. No. Hey, Nolan. Nolan. I was gonna hold it up and see if you went and grab those. Yeah, this one.
I think I might be getting it.
I don't know. I feel seen. Is it not being weird?
I got one. Oh,
Just because like I got contaminated and I was like, oh, I'll just like boil it out.
Yeah.
So I boiled it out. I got one minus nine squared theta.
Okay,
And then that.
so I just have it done. Okay, so, let me boil. I just, because you have to, when you do you have to do it to the nearest, so you have to boil.
So I was supposed to boil the
Yeah, because you have to do, it's like,
oh my gosh, I can't even add. That's the problem here. So this one, did you get this part? And you, okay. So then you have 2 over sine. So 1 over sine is cosecant, but we have 2 over sine, so it's 2. There's like 2 over sine is the same as 2 over sine. 2 over sine theta and 2 over 1 over sine theta. Or cosecant, right? Okay. This one's cosecant because then you have 2 of this. You just know from these, 1 over sine is cosecant. Then this time you have 2 over sine, so it's 2 cosecant. Make sense?
Okay, so I need to find common denominators here.
Oh, so I was supposed to boil these out.
Everything's already matching, so I can just bring that one down. There's a difference between the old denominator and the new denominator, missing a sign.
Yeah, you just get, and then that actually goes cosine. All right, so I got the bottom. Good to know.
Clean this up. Oh, sorry. Now that we have common denominators, I can push these together under one fraction. One minus sine squared becomes cosine squared. We see some common factors that we can take out. We're left with cosine over sine. That gives us cotangent. Okay, any questions with 3? Number 4, very similar to number 3 in the sense that I have 2 fractions, but I need to end up with one term, so that's an indication that I probably need to go through common denominators. So my common denominator, I need both to create my common denominator. So now we got to compare, right? What is different between the old and the new denominator? Whatever is different is what we need to include as a balancing term for our numerator. This denominator is missing a sine theta. So the balancing act is I need a sine theta for the numerator. Sine times sine is sine squared. Second fraction, old denominator versus new denominator. This is missing a 1 minus cosine, so I need to balance this numerator with a 1 minus cosine theta. So we got to be careful here. When you do 1 minus cosine times 1 minus cosine, we got to FOIL this out. There's going to be 4 terms that's going to come out of this. Everybody okay with the expansion from the 1 minus cosine to here? So now that I've common denominators, I'm going to make it all one fraction and then see what can merge and go away. Yes?
What happens if you don't expand it and you just cross and you divide the 1 minus cosine squared by the 1 minus cosine?
Oh, you mean take this out?
No, what if I didn't factor the top 1 minus cosine?
Then I feel like it'll be harder to know how to merge with that sine squared.
I mean, it's just sine squared plus 1 minus cosine squared.
You mean like this?
I'll show you my paper. This is what I did.
So these are, this is not the same thing as 1 minus cosine.
Okay.
These are not the same.
I'll put the parentheses then.
So now I got to fold this out.
What if I didn't put it? I just did this.
Then it's harder to know exactly what can cancel out.
Can I not divide these two? These two?
Because there's a plus sign in between.
Got it.
And it makes it, if it was multiplication,
If it was
fair game.
multiplication, then you could do it.
Yeah.
Got it.
Addition, you can't, yeah. Okay. The sine squared and cosine squared can merge nicely for us. We have an identity that we can apply here. Sine squared plus cosine squared is 1. And then, because that's 1, we have another 1 here. 1 plus 1 is 2. You guys see that? So now that we're here, we can we see some similarities now, right? 2 minus 2 cosine theta looks kind of like 1 minus cosine theta, but I can maybe make it even more similar if I can do something with this 2 minus 2 cosine theta. I can factor a 2 out. But once that 2 gets factored out, what I'm really doing is I'm dividing each term by 2 and putting the leftover in its own set of parentheses. 2 over 2 is 1. 2 over 2 is also 1, but we're left with cosine theta. Got some nice matching terms there. And we're left with 2 over sine theta. Okay, we're close. We know sine and cosecant are related. They are reciprocals of each other. We know sine is just 1 over cosecant. And if I flip that up, I get 2 cosecant theta. Any questions with 4? Okay, I'll leave that up for a second. And then we can turn over and try number 5. Okay, are we good here? Number 5? Very similar to the previous problems here. I see 2 fractions. I see only one term on the right. I would like to merge them together to see if I can get that down to one term. Okay, common denominator. So now that I've created a common denominator, I have to figure out if there's any balancing that needs to be done between old and new denominator. Here, my old denominator is missing a 1 minus sine theta, so I need to multiply numerator by 1 minus sine theta. This second fraction is missing a 1 plus sine theta. So I'll multiply this by 1 plus sine theta. Push all that together. Combine like terms. The middle terms drop out. Well, not middle terms, but the cosine sign drops out. What's left in the numerator? What's cosine plus cosine? 2 cosine. Yeah, 2 cosine. So every step I take, I'm always looking at the right side to see how can I get even closer to my answer. You notice that secant is related to cosine. So looks like we would like to get everything in terms of cosine. Maybe that will kind of help create something out of secant to get that secant. So I'm going to FOIL the denominator out because I know that it'll hopefully lead me to a trig identity to push it to be in terms of cosine. One minus sine squared is nicely a trig identity, Pythagorean identity. This becomes cosine squared. One of the cosines can go away. You know, cosine and secant are reciprocals. Push that up, make it secant. And there we have our end.
So on the 2 cosine theta over 1 plus sine theta, 1 minus sine theta, you.
Oh, I pulled this out, so let me show you that. So 1 times 1 is 1. Minus sine theta plus sine theta minus sine squared theta. So technically there are 4 terms, but the middle terms drop out. So I'm left with 1 minus sine squared.
Okay.
Question with 5?
So when every time you find common denominator, you have to boil, right?
Not every time. It really depends on what the right side is kind of telling you to do. Sometimes you may need to leave it in factored form because something will cancel out. Other times we're expanding in the hopes of getting closer to our goal. Yeah, so the reason why I expanded out is because I knew that I would get a trig identity that will push me towards cosine, and cosine will get me closer towards secant. Yeah, so the right side will kind of help giving me, keeps giving me ideas as to how to move forward. Okay, next, number 6. Cosecant to the 4th minus cotangent to the 4th equals 2 cotangent squared plus 1. We need to recognize this as a factoring opportunity. This is, there's a formula here. It's basically difference of squares. If I have a to the 4th minus b to the 4th, that's the same thing as a squared minus b squared times a squared plus b squared. We're just splitting each term into its square root terms, and then we're making a difference of squares. So I'm going to apply that here as well.
So if you see something to the 4th, then most likely it will be difference.
If there's a minus in between, I mean, if it was cosecant to the 4th plus, 3 cosecant to the 4th plus or times sine, then there's a GCF that comes out, right? Okay, so everybody good with identifying difference of squares and applying it? Okay. So my next step is there an identity that I can use? Looks like there's one for this, right? What's cosecant squared minus cotangent squared?
1 plus
Just 1, right? So if we look, cosecant squared minus cotangent squared is equal to 1. But I don't have an identity for cosecant squared plus cotangent squared, which is okay. We're just going to go ahead and copy that down. But at least this piece is gone. So now we're just down to this.
But cosecant has an identity.
I'm sorry?
Cosecant squared still has an identity. Which is the 1 plus cotangent squared.
It does, yeah. So I'm leaving it in this form for now because I always want to take a look at my right side. Maybe you've already done this, but I'm looking at my right side to see, okay, which do I want to replace to get closer to my goal? So I'm not going to replace the cotangent squared because it's already in terms of cotangent squared. I want this cosecant squared to go away. So now I'm going to look for an identity that will convert cosecant squared in terms of cotangent squared, which is 1 plus cotangent squared. So now we're at the end, right? Cotangent plus cotangent, we get 2 cotangents. Yes.
So where'd you get the cosecant squared minus cotangent?
So you see how this is in the form of a to the 4th minus b to the 4th? So I'm basically splitting them up into a squared minus b squared.
Not that, but like where'd you get it?
Okay. because this is based off of this identity here. Because 1 plus cotangent squared equals cosecant squared, if I move things around, cosecant squared minus cotangent squared is equal to 1.
Okay.
Yeah. But I'm not able to do anything with this because the identity didn't quite work, no matter how I arranged it. Yeah.
Wouldn't there be 2 1s? Because the one from cosecant squared minus cotangent squared, and then the one from converting cosecant squared into 1 plus cotangent squared. So wouldn't that be like 1?
Okay, yeah. Okay, so this is being multiplied. So it kind of just goes away. It kind of goes away, right? Okay, number 7. Are we okay? Up to 6? Okay, 7. So 7, we do need to recognize there's something going on with this form here. This is a trinomial factoring problem. So let me do a version of this problem that's more recognizable. X squared plus 2x minus 3. Do you see a resemblance between these two? It's just an easier version of this problem. So what we're going to do is, let's just go ahead and factor this easier problem, and then we can just convert it back in terms of cosecant. How's that? So how would you factor this? Multiplies to be negative 3 and adds it to be 2.
X minus, X plus 3.
Yeah. So we know we can factor this easy problem, so now we can just replace x in terms of cosecant, and we have the factor form of this. And I'm looking for an opportunity to do some cleanup here. Cosecant squared theta minus 1. I know that there's an identity here, but I'm not going to use the identity because I want everything in terms of cosecant. So what's another thing that we can do besides an identity? We can factor this, right? This is a difference of squares. A squared minus b squared is a minus b times a plus b.
Then you cross out the CSC minus 1.
There we go.
Ignore the
Cosecant theta minus 1 goes away, and we have our goal. Okay, number 8. We're trying to get from 1 plus cosine over sine to be cosecant over cotangent. Any idea for our first step?
Break it up.
Break it up. Because I'm thinking, well, if I get this into 2 fractions, then I have 2 terms, and I can just try to clean up both terms, and hopefully one will turn into cosecant and the other into cotangent. One over sine. Yeah. Cosine over sine. Okay, questions?
Can you just go through number 4?
So number 4, I see that there is a common denominator needed. Anytime I see 2 terms on the left and 1 term on the right, I know I want to try to push those 2 things together. My common denominator is sine of theta and 1 minus cosine theta. Once I have my common denominator identified, I'm going to go through and balance each fraction to see what is missing between my old and new denominator. So here, my old denominator is missing a sine theta, so I need to multiply the top by sine theta. Sine times sine gives me sine squared. Second fraction, old to new. I'm missing a 1 minus cosine, so I need to multiply the numerator by 1 minus cosine. Careful, if you see 1 minus cosine times 1 minus cosine, we can't just make it 1 minus cosine squared. We really want to take the time to FOIL this out. So distribute, you get 4 terms, 1 minus cosine plus cosine squared. We're going to take advantage of the fact that we now have common denominators. We can merge the numerators together. So I put all these terms together. Minus negative cosine is negative cosine, negative 2 cosine. And now I'm looking for any other ways to clean this up. I see an identity that I can apply. Sine squared plus cosine squared is 1. There's another 1 here, so 1 plus 1 is 2. So I'm left with 2 minus 2 cosine theta. And I am not distributing the sign through because I'm waiting to see if there's anything that I can do with this. Right. So typically, I would like to leave my denominator in factored form with parentheses until I get some idea as to, is the numerator going to, is there something that I can match up and cancel out? And once I've decided that, you know, if there's nothing to cancel out, then maybe I want to distribute to make it closer to what my end goal is. But here, I'm leaving my denominator in factored form. And we see that if we were to factor that 2 out, we get that clean match that would otherwise be more difficult to see if you were to distribute that sign a little earlier, right? So you want to hold on to your factored form as long as possible until you're convinced that you should be distributing through, right? Because it's easier to see the different parts if you have everything in factored form. Okay, so you're left with 2 over sine. Sine and cosecant are reciprocals. We can bring that up. We get 2 cosecant. Okay, anything else?